Hi, welcome to another video. Today we'll be solving the question of merging k-sorted linked lists. So here we are given the question, and here we have k linked lists. Each linked list is sorted in ascending order, and we have to merge all the linked lists into one sorted linked list and return it. So here we have this example, and I have drawn these k linked lists. So here k is equal to 8. K is equal to 8, and I've just called it n instead of k, so it's either n or k. So what we have to do is we have to merge these k linked lists and return a final linked list. So here I have assumed that k or n is equal to 8, and here I have just drawn the heads of the k linked lists. So this list 0 is the first linked list, this is second linked list, and this one is ninth linked list. So here what we are going to do is we're going to use a technique of divide and conquer to solve this question. So divide and conquer is generally used when we have to do pairwise processing, and with pairwise processing, so here we can merge the linked list 0 at index 0 and then linked list at index 1, and we can make it into a bigger linked list. So, and we basically process the linked list pairwise and we produce a single output. So here if I have n individual units, and finally I have to produce one bigger unit using these n units. So in divide and conquer, we are going to merge these linked lists pairwise. So to understand it easier, I have drawn this example. So here we have indexes 0, 1 up to 8. So in our previous question where we solved the question of merging two sorted lists, we are going to use the same function to merge these linked lists pairwise. So what I'm going to do is I'm going to call this merge function on lists at index I and list at index I plus increment. So here increment is the difference between the two linked lists. So basically the difference between the index of the two linked lists. So here, as you can see, the difference between these two linked lists is simply currently 1, these two ones, and the second pair is also 1, and third pair the difference is 1. So as I merge these pairs, I am going to set the final result into lists I. So here my final linked list will start from the original linked list. So basically the head of the merged linked list, it would be list 0, the head of linked list at index 0, and then the second pair, the head will start from 2, and then my third pair, the head will start from 4, and so on. And in my next iteration, now I have to merge the linked list at index 0 and then index 2, and then I will decompose it into a bigger linked list, and then it would start from index 0. So here, as you can see, the difference between the indexes is now equal to 2. And if we go ahead, now the difference will become 4. Now I'm going to merge the linked list starting at index 0 and then linked list starting at index 4. So now these two linked lists, they are bigger and they have more elements. And now the difference between the indexes is 4. And finally we are left with 0 and 8, and then we can merge them and we can get our final linked list. And at the end we can simply return list 0, which would be head of our final merged linked list. So here, as you can see, the difference is increasing in power of 2. So here it is 2 to the power of 0, then it is 2 to the power of 1, then it is 2 square, and then it is 2 cube. And I'm merging lists at index I and I plus increment. And for checking out of bounds, this I plus increment should be less than length, and this would be our merge operation. And once we are done merging lists at index I and I plus increment, then I have to increment my I as well. So here, as you can see, we can figure out the logic for incrementing I. So here my I is 0, and then when I'm done merging 0 and 1, I have to set I equal to 2. And when in my second iteration, when I'm done merging 0 and 2, I have to move I equal to 4. So let's see what I can be. So I is going to be equal to I plus 2 times increment. So here, as you can see, my increment is 1. So 0 plus 2 into 1 will give me 2. And then for my next iteration, I would be 2, and then it would be 2 plus 2 into 1, and this would be equal to 4. And for my next level, I is initially 0 and my increment is equal to 2 now. So I would be equal to 0 plus 2 times 2, and it would be equal to 4. And then next it would be 4 plus 2 times 2, which would be equal to 8. And I can increment my increment variable by just multiplying it by 2. So increment would be simply equal to 2 times increment. And the while check for increment would be, so increment should be less than length. So this would make more sense when we are writing the code. So let's dive into the code implementation for this problem. So now let's have a look at the code implementation for this problem. So here I have copied our merge 2 lists from the previous problem of merging 2 sorted linked lists, and now we have to merge k sorted lists. So as we discussed, we need an increment variable. So let me assign to 1, and initially I have to set I equal to 0. So let's first write simply just write list I equal to merge 2 lists, and then it would be lists I, and then lists I plus increment. And as we discussed, like after merging, we have to increment I. So now I can figure out my for loop conditions easily. So here, let me copy this. So as we discussed, our I should be equal to I plus 2 times increment. So either we can do it here, or we can simply have it here in our for check. And initially we have to set I equal to 0, and I plus increment should be less than length. And now we have to create length variable as well. So it will be list.length. So basically we are building this loop from bottom up rather than writing it from top down to just understand it better. So that's why I started writing from here and then build our for loop. So once we are done with a particular level, now we have to update the value of increment. So after the for loop, we know that increment is going to be equal to increment times 2, and outside it's going to be another loop, and and here I can have increment less than length, and then I can simply copy paste it in there. And as we know, at the end we have to return list 0, which would be final merged linked list, which would be the head of final linked list and containing all the elements from given k sorted linked lists. And another check we have to do is we have to check if length is equal to 0. So for that I can add length equal to 0 and I can simply return null. So yeah, this is the function that we implemented in our previous problem of merging two sorted linked lists. So let's try to run it and see what happens. So yeah, that works, which is good. And let's try to submit. And yeah, that works as well. So I hope this made sense mathematically. The conditions that we are using, we are doubling the increment, and we have how we are incrementing our I variable. And this is the optimal approach because it reduces the number of calls to merge two lists function. We could have simply used this merge two lists by like first merging the list at 0 and then 1, then take the result and then merge the second one, and then take the result and then merge third one. That would just increase the number of calls to merge two lists function. So divide and conquer, it reduces the number of calls. So that is why it's optimal. So I hope this made sense. And if you have any doubts, let me know in the comments. And I'll see you in the next one. Thank you for watching.